Hello friends, welcome to Head or Tail Education. Today our topic is comparison of linear motion and rotational motion in physics. Now we know all the formulas of in linear motion is equivalent to rotation motion. So first is the initial mass and in linear motion, and in rotational motion moment of inertia. So what is the initial mass? So the initial mass is the property of an object that resists any change in its state or motion, whether that's from rest or moving at a constant velocity. So this is called initial mass. Next, moment of inertia is, so the moment of inertia is an object resist to angular acceleration. So this is the moment of inertia. Next is in linear motion is displacement. In equivalent to rotation motion is angular displacement. In linear displacement, the symbolic is s, and angular displacement is theta. So displacement is if any object position is changed from old position to new position is called displacement. It's simple. Next, respect of angular displacement, the change in an object's rotational position around a fixed axis or point. So this is called angular displacement. Next is linear motion velocity, means linear velocity represented by v. Respect to angular motion is represented by omega. So velocity in case of linear motion, the rate of change in displacement is called velocity. Okay. Next, respect of in angular velocity, which is showed by omega. So angular velocity, rate of change in angular displacement is called angular velocity. In linear motion, we have the acceleration. So what is the linear acceleration? So linear acceleration is rate of change in velocity is called acceleration. It is the simple definition. So we know that a equals to dv by dt, and again we use the wake means velocity formula. So use is d square s by dt square. Okay. Respect in angular acceleration, so rate of change in angular velocity is called angular acceleration. So represent by alpha. So alpha equals to d omega by dt equals to d square theta by dt square, because we put the value of omega here. Okay. Next is linear momentum in linear motion. So linear momentum p equals to m is multiplied by v. So what is the linear momentum? The mass of object is multiplied by velocity is called linear momentum. Same like available in angular momentum, represented by L. So L equals to I is multiplied by omega, means angular velocity multiply. So angular momentum is called the moment of inertia. It is multiplied by angular velocity is called angular momentum. Next is force. In linear motion we have the force. So force F equals to ma, we all know. Okay. Now next A is represented by dv by dt, means change of velocity rate. Okay. And again if we use m is multiplied by v, so we can write here the linear momentum p. So change of linear momentum p is called force, or like force definition is if any object is stable or moving state, then change the state of object by any action is called force. Okay. Now the same like torque. So torque is how much a force acting on an object to rotate is called torque. Okay, so to rotate any object we give the force is called torque. Okay, the same like, so torque equals to I into alpha. Now alpha, what is alpha? Alpha equals to dw by dt. So we write here, or now what is the dw by dt? Here if we multiply by I into omega, so again L, angular momentum, so dl by dt. So change in angular momentum is called torque. Okay, next impulse, symbolized by both sides is J, but only the change in respect the linear motion. So impulse is J equals to force is multiplied by delta t, means duration of time. Okay, so definition is impulse in case of linear motion, so a large force is applied very short duration is called impulse in linear motion. Now next respect to in rotation motion, so rotation motion is J equals to torque is multiplied by delta t, means short duration again. So reference the definition is impulse against the rotation motion, the same like torque is applied for rotational object very short duration is called impulse. Okay, now next is kinetic energy. In linear motion we have the kinetic energy, so E equals to half mv square. This is the formula of kinetic energy. So what is the kinetic energy? The energy an object possesses due to its motion. When object is motion, so we have the kinetic energy. Okay, the same is like rotational kinetic energy, so er equals to half I is multiplied by omega square, means angular velocity square, and I is initial moment of inertia. So rotational energy is due to rotation of object, so when object is rotate we have the rotation kinetic energy. Okay, next is work also both side. So in linear motion what is the definition of work is equal to force is multiplied by s, so a force that causes an object to move, so this is called work. Now in respect to rotation, so our torque that causes an object to rotate, so if we any object is rotate by using the torque is called work. Okay, next power. So what is the power? In simple definition, the capacity of work is called power. Okay, so the same, the formula is equals to P equals to dw by dt, means rate of work. Now equals to force into distance, means S divided by dt. So again we equal to, so F is the same, this is the force, and S upon dt equals to, means distance by dt equals to V. So we create here like F into V. Okay, now in angular rotation motion, the force means the power equals to the angular rotation capacity of work is called power. So you know the if any object is rotate very fast, slow, medium, so this is called the power. Okay, now next the relation between momentum p and kinetic energy. So what is the relation between in both? Means momentum p and kinetic energy. It's simple. So p equals to square root of 2 times multiply mass into energy. So this is the relation of this. Now next rotation motion. Same like relation between angular momentum L and rotation kinetic energy ER, which is equals to, so what is the relation is, so L equals to square root, so multiply by 2 into multiply by I, means moment of inertia, and ER means rotation kinetic energy. So this is the relation between angular momentum L and rotation kinetic energy. Now next is the equations of velocities in respect to linear motion. So what is this? So first is equals to v equals to u plus at. Means v is the velocity, u is initial velocity of object, a is acceleration and t is time. First, next s means distance, duri. So s equals to ut plus half at square. So we know that s is distance, u is initial velocity, t is time, or a is acceleration. Now next is v square equal to u square plus 2as. So v square is the velocity, final velocity, u square is initial velocity, and multiply by 2, a is acceleration and s is distance. So same like in rotation motion with respect to angular velocity. So we have the omega equals to omega 0 plus alpha t. Means omega is final velocity, omega 0 is initial velocity of object, alpha is angular acceleration, and t is time. Now distance s equals to theta. So theta equals to omega 0 t plus half at square, half alpha square. Means so omega 0 is initial velocity is multiplied by time, and plus half the angular acceleration is multiplied by t square, time. Okay, now next omega square, final velocity, equals to omega 0 square initial velocity plus 2 alpha s. Means acceleration, angular acceleration is multiplied by s. So this is the equations of angular velocity and comparison the equation of linear velocity. Now tell summary. Finally, we learned difference between by using the comparison of linear motion and rotation motion in physics. Hope tutorial is very helpful to you understand both motion in physics. Thanks to watch Head or Tail Education.